Everything you see around you, every object you touch, every sensation you feel is not made of matter. It is not made of energy. It is not made of particles or fields or any physical substance you can name. It is made of information, not information about physical things, not information encoded in physical substrates, just information, pure abstract mathematical information. And that information is all there is. The chair you are sitting in is information. Your body is information. Your thoughts are information processing information. The entire universe, from the smallest quantum fluctuation to the largest galaxy cluster, is nothing but information organized in extraordinarily complex patterns. This is not a metaphor. This is not philosophy. This is what physics is telling us, and I'm going to explain why you should take it seriously, even though it sounds completely insane. Let me start with something concrete: a black hole. When you throw something into a black hole, what happens to it? Classically, it falls through the event horizon and continues falling toward the singularity at the center. The object is gone, lost forever behind a boundary that nothing can cross from the inside. But quantum mechanics says something different. Quantum mechanics says information cannot be destroyed, ever. The quantum state that described that object must be preserved somewhere. But where? The object fell into the black hole. It is inside. We are outside. How do we access information that is trapped behind a horizon we cannot cross? Stephen Hawking complicated this dramatically when he discovered that black holes radiate. They emit thermal radiation, photons, and they slowly evaporate. Eventually, a black hole can evaporate completely. It radiates away all its mass and disappears. Hawking initially thought the radiation was completely random, thermal. It carried no information about what fell into the black hole. If that were true, then the black hole evaporating would destroy all the information about everything that ever fell in. Quantum information would be lost. The evolution of quantum states would not be reversible. Quantum mechanics would be violated. I did not believe this. I spent years arguing with Hawking about it. We had a famous bet, and eventually Hawking conceded. The information is not lost, but where does it go? The only place it can go is into the Hawking radiation. The photons that the black hole emits must carry information about everything that fell in. But Hawking radiation is thermal, random. How can random radiation carry specific information about a book or a computer or a star that fell into the black hole millions of years ago? The answer is that the radiation is not truly random. It is pseudo-random. It looks random if you measure simple properties. But if you could measure the exact quantum state of every photon, if you could track all the subtle correlations between photons emitted at different times, you could in principle reconstruct everything that fell in. The information is scrambled, encoded in incredibly subtle correlations, but it is there, preserved. But here is the shocking part. If all the information about everything inside the black hole is carried by the radiation that comes out, then the information must have been on the surface the whole time, not inside, on the surface, on the event horizon. This is impossible in three-dimensional geometry. The amount of information that can be stored in a volume should be proportional to the volume, but for black holes, it is proportional to the surface area, to the area of the event horizon. The three-dimensional interior is redundant. Everything that appears to be inside is actually encoded on the two-dimensional surface. The black hole is a hologram. This is the holographic principle, and if it applies to black holes, it might apply everywhere. Any region of space, not just black holes. The information in that region is fully encoded on its boundary. The three-dimensional volume is a projection, a holographic image, not the fundamental reality. The fundamental reality is the information on the boundary, and that information is two-dimensional. Space has one less dimension than it appears to have. The depth you perceive, the volume you inhabit, is an illusion created by the way information is organized on a surface. Does that sound crazy? It should. It contradicts everything your experience tells you about reality. But the mathematics works, the physics works, and experiments, though they cannot directly test the holographic principle yet, have not contradicted it. Every calculation we do in quantum gravity that involves holography gives consistent, sensible answers. The universe might actually be a hologram, and if it is, then the matter and energy you think fill three-dimensional space are not fundamental. They are holographic projections of information living on a distant boundary. What is information? That is the question we need to answer if we are going to take seriously the idea that reality is made of it. In everyday language, information is what you learn when someone tells you something you did not know. It is a reduction of uncertainty. Before you flip a coin, you are uncertain whether it will be heads or tails. After you flip it, you know. You gained one bit of information. A bit is the fundamental unit, a distinction between two possibilities, yes or no, 0 or 1, true or false. Every piece of information can be decomposed into bits. This sentence contains information measurable in bits. Your genome contains information measurable in bits. The state of every atom in your body contains information measurable in bits. But information is not just a way of measuring knowledge. It is physical. This is what quantum information theory taught us. Information has physical properties. It cannot be copied perfectly. This is the no cloning theorem. If you have a quantum state and you do not know what it is, you cannot make an exact duplicate. Classical information can be copied as many times as you want without degradation. Quantum information cannot. This is not a limitation of technology. It is a fundamental law of physics. Information is a thing. It has properties. It obeys laws. It is not reducible to something more fundamental. It might be the most fundamental thing there is. In quantum mechanics, the state of a system is described by a wave function. The wave function assigns a complex number, an amplitude, to every possible configuration the system could be in. Those amplitudes encode all the information about the system. Everything you could possibly learn by measuring the system is contained in the wave function. And the wave function evolves according to the Schrödinger equation, which is a deterministic equation. Given the wave function at one time, you can calculate exactly what it will be at any other time. The evolution preserves information. No information is created. No information is destroyed. The total information in the universe is constant. But here is the key insight. The wave function is not a property of the physical object. It is not something that exists in space like a field. It is an element of an abstract mathematical space called Hilbert space. Hilbert space is infinite dimensional. The wave function is a vector in that space, and quantum mechanics is a theory about how that vector rotates in Hilbert space over time. It is not a theory about objects in physical space. It is a theory about information in an abstract space. Physical space emerges from the structure of that information. Space is a projection, an effective description, a way of organizing information that makes certain calculations easier. But fundamentally, there is no space. There is only Hilbert space, only quantum information, only the abstract structure of the wave function. Let me tell you about entanglement, because it is the clearest demonstration that information is fundamental and space is emergent. When two particles are entangled, they share a single quantum state. That state cannot be factored into separate states for each particle. You cannot describe particle A independently of particle B. They are correlated in a way that has no classical analog. If you measure a property of particle A, you instantly know something about particle B, no matter how far apart they are, not because a signal traveled between them, because they share information. They are part of one quantum system described by one wave function. This is non-local. The correlation is instantaneous. It does not respect spatial separation, and this tells you something profound. Spatial separation is not fundamental. Entanglement is more fundamental than distance. Two entangled particles are closer to each other informationally than two unentangled particles sitting side by side. The closeness is not in space. It is in Hilbert space. It is in the structure of quantum information. And if entanglement is more fundamental than spatial separation, then space is emergent. Space arises from patterns of entanglement. This is the insight that drives modern quantum gravity research. There is a formula that makes this precise, the Ryu-Takayanagi formula. It relates the entanglement entropy of a region, which measures how much quantum information is shared between that region and its surroundings, to a geometric area in a higher dimensional space-time. The formula says that geometry emerges from entanglement, that the curvature of space, the distances between points, the very fabric of space-time are all reflections of how quantum information is organized and correlated. Space is not the arena where physics happens. Space is a bookkeeping device, a way of organizing information, and the information is primary. The space is derivative. If space is emergent, what about time? Is time emergent too? I think it is. In the Wheeler-DeWitt equation, which describes quantum cosmology, time does not appear. The equation describes a static quantum state of the universe. Nothing changes, nothing evolves. This seems paradoxical because we experience time, we experience change, but the resolution is that time emerges when you describe the universe from the perspective of a subsystem. One part of the universe acts as a clock. Other parts change relative to that clock. But globally, the universal wave function is timeless. Time is an internal correlation, a feature of how subsystems within the universe are entangled with each other, not a fundamental background structure. So, if space is emergent and time is emergent, then space-time is emergent. And if space-time is emergent, then everything that exists in space-time is emergent. Matter and energy are patterns in space-time. They are excitations of quantum fields. But if space-time is not fundamental, then matter and energy are not fundamental either. They are high-level emergent phenomena arising from the fundamental information structure. What is fundamental is quantum information. The universe is not made of stuff. It is made of bits, qubits, quantum bits, units of information that can be in superposition and entanglement. And the physical world we perceive is the macroscopic pattern that emerges when you have an unimaginably vast number of qubits organized in very specific ways. Let me tell you about an idea that I find both compelling and disturbing, it from Bit. This is John Wheeler's phrase. He proposed that every physical thing, every it, every particle, every field, every observable, derives its existence from binary questions, from yes or no answers, from information, from bits. The universe is fundamentally not made of matter. It is made of answers to questions. You might think questions require someone to ask them, but Wheeler meant something different. The universe asks itself questions through physical processes. A measurement is a question. An interaction is a question. The outcome is an answer. And the totality of all questions and all answers is what constitutes reality. Information is not describing reality. Information is reality. Does this mean the universe is a computer? Many people jump to that conclusion. If reality is information processing, then it must be computation. And if it is computation, then maybe we are living in a simulation. Some computer in a higher reality is running our universe as a program. I do not think this follows. Information and computation are not the same thing. Computation is information processing according to specific algorithms designed to achieve specific results. The universe processes information, yes, but it is not following an algorithm we programmed. It is following the laws of physics. Those laws determine how quantum information evolves, and whether you call that computation or not is a matter of definition. The important point is that information is the substrate. the thing from which everything else emerges. Whether you label it computation misses the deeper insight. What about consciousness? If reality is information, what is the information that corresponds to your subjective experience? Your thoughts, your sensations, your sense of being a conscious self? I have struggled with this question for years. There is growing evidence that consciousness is related to information integration. When different parts of your brain share information, when they are highly interconnected and processing information in coordinated ways, consciousness emerges. Simple systems that process information but do not integrate it, like a collection of independent circuits, are not conscious. Complex systems that integrate information across many modules, like brains, are conscious. The amount of consciousness might be related to how much information is integrated, how many bits are bound together into a unified whole. This is integrated information theory proposed by Giulio Tononi. It is controversial, but it fits naturally with the idea that reality is information. If the universe is made of information and consciousness is information integration, then consciousness is not separate from the physical universe. It is a particular pattern of information processing, a particular way that quantum information can be organized. Your subjective experience is what it feels like from the inside to be a certain pattern of integrated information. The redness of red, the sound of middle C, the pain of a stubbed toe, these are the internal signatures of specific information processing patterns. They are not separate from the information. They are the information experienced from the inside. If this is right, then the hard problem of consciousness, the question of why there is something it is like to be conscious, might dissolve. There is something it is like to be a pattern of integrated information, because that is what integrated information is. From the outside, you see neurons firing in complex patterns. From the inside, you experience thoughts and sensations. They are not two separate things. They are two perspectives on the same information processing. The outside view and the inside view, the map and the territory, are one. Let me tell you what all of this means for the nature of reality. Reality is not made of stuff. It is made of structure, patterns of information, correlations between qubits, entanglement structures in Hilbert space. The material world is an emergent approximation, a useful description at large scales where quantum effects average out and classical behavior emerges. But fundamentally, there are no particles, no fields, no forces, just information evolving according to laws we call quantum mechanics and quantum field theory, and at the deepest level we currently understand, perhaps quantum gravity. This is a radically different ontology from what physics assumed for centuries. Newton thought the universe was made of particles moving through absolute space and time according to deterministic laws. Einstein refined this, unifying space and time into space-time and showing that matter and geometry are interrelated. But both still assumed there was stuff, objects, things with properties existing in a background space-time. Quantum mechanics challenged this, showing that properties are not definite until measured. But most physicists still imagine quantum fields as things existing in space-time, even if those things behaved strangely. What I am telling you goes further. There are no things. There is no background space-time. There is only information, quantum information, and all the things you think are real, particles and fields and space-time itself, are patterns in that information, emergent structures, useful approximations, but not the fundamental reality. Why should you believe this? Because it works. The holographic principle works. Calculations in quantum gravity using holographic methods give consistent answers. The Ryu-Takayanagi formula relating entanglement to geometry is confirmed in the cases where we can check it. The idea that space-time emerges from entanglement is producing new insights into quantum gravity. The idea that physics is fundamentally about information, is not just philosophy, It is guiding real research, suggesting new experiments, solving problems that resisted solution for decades. If information were just a way of talking about physical systems, it would not be so central. But it is. Every calculation we do, every theory we write, every prediction we make comes down to asking what information is available and how that information transforms. Information is not something physics studies. Information is what physics is. After 60 years of thinking about these problems, I have come to believe that John Wheeler was right. It from bit. Everything from information. The universe is not made of matter that stores information. The universe is information that creates the illusion of matter. Your body is not an object that contains information in its cells and synapses. Your body is a pattern of information that has organized itself to be self-sustaining and self-aware. You are not in the universe. You are a part of how the universe processes information about itself. You are the universe looking at itself and wondering what it is. And what it is, at the deepest level, is information, bits, qubits, quantum states, mathematical structures in Hilbert space, evolving according to laws that preserve and transform information but never create or destroy it. Reality is information, not information about something else, just information, information all the way down, and that information organized in patterns of extraordinary complexity and beauty is everything. Everything you see, everything you are, everything that exists. It is not metaphor, it is physics, and it might be the deepest truth we have discovered about the nature of existence.